Hello, good evening. Thank you all for being here. I'm very happy to see you. Uh, Today we're going to talk about one of the things that I find super exciting in Unity. And even before joining Unity, most of my game dev professional experience was making 2D games. And I have this special interest in 2D stuff, in cartoons, etc. So to me, it's really exciting to talk about this topic right now. First, I'd like to ask you, who here is working on a 2D game? Okay. Okay, I will say 1/3 of the audience. Who is working on a 3D game? Is the rest of the audience? Okay, cool. So, of course, we're going to talk about 2D today, but I hope everyone can find something useful. Maybe even if you're working on a 3D game, you want to see which parts of what we will see today can be used in your game. Okay. So my name is Arturo Núñez. I'm a product evangelist at Unity Technologies. I come from Mexico, and that's my Twitter account. My email is arturo@unity3d.com. So if you have any question related to whatever we see today or any other Unity thing, please feel free to reach out to me. I will be happy to answer you. You can send me emails in English and Spanish. Because I don't speak Korean, I'm sorry. But yeah, I will be happy to have contact with you. Okay, so what are the objectives of this presentation? Which, by the way, will be a short presentation, so don't worry. I know you are maybe a bit tired of having attended other presentations. But basically, there are 3 things that I would like you to take away from this presentation. The first is that you have enough information to select the best animation technique for your game. Whatever I present you today is not going to be, I'm not going to tell you, oh, you should use this technique or you should use this tool or whatever. I just want to show you a couple of ways of doing animation in 2D, and you then will be able to select whatever fits better to your project. After that, we will learn how to animate a 2D humanoid character using Animate 2D, and I will talk about that in a second. And then you will be able to understand where we're heading to on regards of the 2D animation inside Unity. Okay, so first things off, what is animation? We define it as the illusion of life. Basically, when we are making games, what we want to achieve is that the player feels like he's inside the game, right? Or he's interacting with the game. If we have good animations, we have a good frame rate, we have a good experience, then the player will feel like he's in the game or he's interacting with the game. However, if something breaks, and in this case, if animation breaks or if there's something weird with the animation, the player will stop thinking about, he will start thinking about software. He will start thinking, oh, something went wrong, maybe it was the code, or maybe there's something weird going on. So we want to keep that illusion, right? So that's just the basics of animation. So first, let's get some background on 2 techniques of animating. The first one is what we call the frame-by-frame animation technique. Basically, for each frame of our animations, meaning each pose that we have for our character or any other object that is animated, we have something. Oh, it's super small. Well, you have something like that. You have something called an atlas or a sprite sheet, where you have a lot of similar images. However, each image has a different or a slightly different piece, right? So in this case, we see the Adam character running. And each one of these frames only have a small change. So what we're doing and how we handle that in Unity is we just go through all the frames in that sprite sheet, and if we do that fast enough, that gives us the illusion that the object is actually animating, right? So we do something like go from that frame to the other frame, and so on and so forth. Here's one example of a game that uses that technique called Cuphead. This game looks pretty beautiful. They use this frame-by-frame animation, and on top of that, they also do hand-drawn animation, meaning that each of those characters have lots of animations, and each animation has a lot of frames. This game is targeted toward consoles, so the developers can say, okay, my players, they play on consoles, so they are okay by downloading a 4 gigabyte game, right, if they're playing on a console. However, if we're making mobile games, we cannot do that, right? We cannot let the player download a 4 gigabyte project, so we need to find some way to optimize the thing. The other technique, and it's the one that we will be talking about more today, is the skeletal-based animation. This works similar to how the 3D animation for characters works. Basically, we have we need to construct a skeleton to simulate how a skeleton, for instance, in the human body works, and then we will attach those small pieces of textures, right? So as you can see in the example there, from those cut-out pieces, we generate a character like that one, and then we will be tying the skeleton, the bones, sorry, here, to each one of those images. So what's going to happen if we animate the bones? Whatever is attached to that bone will move accordingly, right? So this is another technique. As you can see here, compared to the other one, we don't have, or if we want to have a lot of animations, we can have more animations without the need of adding more textures, right? So we have these textures in a simple atlas, and I can create more and more animations, and I don't need to create more textures, right? So this is, if we talk about memory, this is better. However, these animations, when we are animating the object and we tell, okay, move your arm like this, those computations take place in the CPU, right? So yeah, we won't be using as much as memory as with the other technique. However, we will be using more CPU. We will be sending more work to the CPU. Depends on what you're achieving or your game. This could be actually a worse option than using frame by frames. For instance, if I want to have a lot of these golems in my game, and all of them are animated, I will be sending a lot of information to the CPU to do computation. So just take that into account. This is an example of a game that uses the skeletal-based animation in Unity for mobile. Okay, so in the past, before we actually were working on native 2D tools inside Unity, one of the workflows that developers making 2D games in Unity had to go through was the fact that they needed to use a 3D software to create a skeleton, create a mesh, as you can see here. This is Maya, and animate the skeleton there. The problem here, or the main problem here, is that you need to learn another software, right? And if you're already making 3D games, then maybe your artists already know how to use Maya, etc. But if you're making 2D games, there's actually no point in bringing another software to the development pipeline, right? So that's what we acquired, something called Anima, and I will show you that. Anima 2D, show you that in a second. Basically, the developers, came to us telling us, oh, you know, that will be good to have. So for now, and since I think it's been 2 months, that's free on the asset store. I will show you how to get that. We will be supporting Anima 2D, and we are also working on something to bring similar tools to the actual Unity engine. So just as a recap, this is a comparison of frame by frame versus skeletal animation. Again, I'm not telling you, oh, you need to use this technique over the other, because it depends on what you're trying to achieve. So if you want to have well, frame by frame will end up with more textures, right? If you have a lot of characters, different characters, and a lot of animations, well, you will end up with larger textures or with more textures. So you will be using more memory. The skeletal animation, on the other side, will have simpler atlases. You will have probably just one atlas, one texture in memory, but you will be sending more work to the CPU, so you will have CPU overhead. Frame by frame is a bit inflexible for changes. Why? Because if we already have all the frames drawn into a texture, and we want to, let's say, change the color of our character, we will need to go back to the image editing program and do all those changes, right? In the case of skeletal animation, you just need to change whatever you have on your atlas, and you're good to go. If you want to do smoother animations in frame by frame, you will need to create more frames, right? If you want to have an animation that goes smoothly from this point to this point, you will need to create more frames. In the skeletal approach, you just need to add to tell the software to do more frames in between. There's no blending in frame by frame. That means that if you have an animation of your character running and you want to switch to the animation of jumping, you will need to draw the in-betweens, right? There's no way to blend. And I put an asterisk there because currently if you go to the internet, you will find some research on 2D blending. However, the results are a bit weird. So yeah, that's what I just put that as a note. Animation blending in the skeletal can be achieved. We don't need to create all the animations and all the blends between our animations, because since everything is being calculated at runtime, the software, in this case Unity and Animate 2D, are able to interpolate between one pose to the other. So no matter at which frame of which animation the character is at, it will be able to switch to any other animation at any other frame. Frame by frame is great for performance. Why? Because it's super optimal to just be switching the frame that we are at. We're not sending a lot of information to the CPU. On the other side, the skeletal animation is great for memory saving. And the cool thing is that we can use both, right? There's no hard limit. No one will tell us, oh, if you select this technique, you cannot use the other one. So for instance, if you want to have a lot of small characters on the background doing something really simple that the player won't be able to see with a lot of detail, you can have a couple of frames, and you can just be switching between the frames, and that will be super fast, and you will have small textures. If you want to have a huge boss that will be on the screen super close to where the player is seeing or is looking at, then maybe you want to have a skeletal character, because you will want to achieve other animations. If you want to have more complex and detailed animations, frame by frame, it's better. Why? Because the artist can create effects or whatever he wants, and he is not restricted to Unity, right? So he can do whatever he wants with Photoshop, add effects, etc. On skeletal, the animations are simply software-driven, which means are getting calculated on Unity. And yeah, one is better for small objects, the other better for large objects. This is just an advice. It depends on your actual game. Okay, so now let's go back to Unity. And as I was telling you, we're going to use Animate 2D, this plugin available for free on the Asset Store. You can go download it. The source code is there, so you can see how that was created, etc. It's a super lightweight plugin, and you will end up with lots of examples, etc. Okay, so that's on the asset store. I will give you the links, and also whatever I show you today will be available on GitHub. I will also give you the link so you can download it and play around with that. Okay, so I have here a character that it's already animated. It's a simple girl that runs, in this case, forever. What's going on here? I'm going to explain what I did in this case. So first things is that we have the Animator Controller. So we're going to be using the animations that we create with Animate 2D the same way we already use them in the Animator Controller. So you can have all the transitions, you can have your state machines, etc. And you don't need to learn anything new to switch between one animation to the other. So everything is the same in this case. So let's give a quick look at our character. In this case, we have a really simple character. It's not really complex. We can take a look, for instance, here. All you see here in white, and in a second I will show you how to do something from scratch, but I think it's better if we see this assembled first. Everything you see here in white, these are bones, and the collection of all those bones is called an skeleton. Right, so we have an skeleton. In this case, this was made specifically for this character. I could, however, just change my textures or my sprites and have a different character reusing the animations and the skeleton. But yeah, most of the time, depending on what your character looks like, you will add more bones or remove bones, and also depending on how do you want the animation to look. If you don't need a lot of details, for instance, you might want to get rid of some details as this over here, right? Maybe this character will not be the main character, so you don't actually care about stuff such as the movement here on the skirt of the character. If you see somewhere over here, maybe that will be too much for certain scenarios, but in this case, we did that. Okay, so we have three components here. Also, it's important to know that everything in Animate 2D follows the workflow of Unity really smoothly, so there's actually not many new concepts to learn. If you already know Unity, it's super simple to use. So we have three things. One is the meshes. We have the actual information of the geometry of our sprites, and I will show you that in a second. We have the bones. This is the skeleton, and we have also these things called IKs, and I will show you just in a second. So if I go to the meshes collection over here, let me look at her face. Well, it doesn't really matter. Maybe the arm, right? Here, if I select the arm, we see over here that we have a script called sprite mesh instance. When we create our sprite meshes, Animate 2D will take care of creating all these components, so don't worry, I will show you that in a second. But basically, what we end up having is a mesh, is geometry. Right, so we are, or Animate 2D is creating a mesh for us, so that's what we end up having by the end of the day here. So we have all these small sprite pieces here, and we will be animating those things. We also have the bones over here. Basically, it's a collection of all those bones that I showed you previously defined. So if I move one bone over here, sorry, I think I'm moving the wrong object. Yeah, sorry. I broke my poor character. Okay, I will use the face, for instance, right? So what we will be animating, what we will be keyframe, is the actual position and rotation of the bones, right? So I will just be moving the bone, and whatever it has attached to will move accordingly. This is done by a process called, I forgot the name. Okay, sorry. Well, let me open that, and I will remember. So here, if I open the sprite mesh over here, oh, sorry, it's binding. So I have, for instance, the bone of the leg of the character over here. And as you can see here, all these vertices are being affected by this bone. So if I move this bone, the vertices that are connected to that bone will move accordingly. So this is the process that you will be following. So let me close this back. That's the other part. And finally, I added something that is also built in Animate 2D, which is the IK handles. Basically, the IK, or inverse kinematics, is a technique that allows us to animate objects, in this case a character, a skeleton, but this also works in robotics, or basically anything that has multiple objects connected in a hierarchy. So if we move, for instance, this character arm, I'm moving just the handle. I'm not actually moving the bone. And everything is being run by an algorithm that can tell, okay, the bones are connected in certain way. So if you try to move the bone further away from where it's the limit, then you won't be able to. So this is basically some extra tool that you can use to have to help you to animate in a simpler way. So that's the IK handles. The same works for here. Now, how the animation actually is done. If you have used the animation window in Unity, you have seen this window over here. You can see that basically we are just using whatever that Unity already provides us to animation, right? So Animate 2D, what it's doing is making easier the fact of animating multiple meshes or sprites at the same time, just by moving the bones or the IK handles instead of moving piece by piece. Because I've seen in real projects characters being animated this way, but manually. So if they rotate the head a bit, they will save the rotation of the head. And it's complex. It's complex to work that way. So what we have here is a simpler way to achieve something like that. So let me show you here. For instance, I have the idle animation. You can see that animation over here. If I scrub over the timeline, you see how the animation gets executed. I have the walk animation, something similar. And Animate 2D actually handles whatever it knows should be a keyframe or not. Let's create a new one. If I just go here to the animation window and I click on Create Clip, I will create a new one called Wave. And I just want my character to say hello. So let's see if I'm a good artist. I'm not an artist, by the way, so sorry about that. Something like this. I will copy the first frame, paste it here. So let's see. Well, imagine she's waving hello at you. It's really simple. Of course, I'm not an artist, so this might look weird. But if I wanted to add more animations, for instance, if you are adding more characters to your game and more content via DLC or whatever, you could be adding more animations without having to add more textures, right? And since everything is just an asset, you could include this easily in updates. So let me show you a couple of extra examples that shows us more things that you could do using something like this. Okay, so click play. You see here my character is doing some attack animation without any sort of sword. So I just click space, and she then gets a sword. Well, it's not a sword, it's a weapon attached to her hand, and then performs the attack animation. And I can loop through all these different weapons. And basically, this is super simple to implement. Since we have the position of the object, we have the position of her hand, of the bone in her hand, we just need to attach our weapon to that hand. So this is actually super simple. If we want to add more weapons to the game via DLC or expansions or whatever, we can do this. If we wanted to achieve something like this using the other technique, the frame by frame, I'm not going to tell you that it's not possible. It is possible, but you will need to take into account an extra object just to know where the weapon should be positioned. And that will end up taking time in the CPU, because we will need to be transforming where the bone should be. So yeah, you will end up with a lot of memory used, and also the CPU overhead of the character doing this. Maybe if it's just one character, it doesn't really matter. But if you want to do a game with lots of objects, interacting, etc., this is where it gets important. Okay? Let me open another example. This is also really cool. Let me activate the gizmos. As you can see here, I've also attached some 2D colliders to some bones of my character. What I'm showing here is that I can have way more complex collisions with something that I already have there, right? I have the rotation and position of where the head should be. So if I just append a collider, in this case a circle collider, I can have interesting collisions with other objects in my game. Oh. So as you can see here, I have the collisions working. For instance, you can see how I use one for the sword. If I change my weapon, I can change the collider. And this is also, again, it's possible if you're using frame-by-frame animation, but you will need to keep track of where the position of the weapon should be placed at, what the scale is, what type of weapon, etc. In this case, we don't have to do that because it's already there. The information of rotations, etc. is already there. So we are just adding an extra object somewhere there. Let me open another example. Oh. Okay, here I just want to show you how the blending will work, right? So we have here our Animator Controller, as you saw before. We didn't make an animation that goes from idle to walk, right? Because it will be a lot of work to create an animation where the character is idling and then switching to walking, and then another from idle to run and from idle to attack. The combinations get crazy as soon as I add more animations. So if we use this technique, the blending is actually comes for free, not on the side of calculating, but we don't need to do that manually, right? So in this case, if I'm from idle, I want to go from idle to walking. All the interpolation, you can maybe see here, happens at runtime. The same for walk, from walk to run. I don't need to actually create the frames in between. And if I have another animation, for instance, wave, when I created my character and my first animations, I didn't know I was going to have a wave animation. So I just make a transition from idle to wave. And all the frames in between will be generated by Animate 2D. So it will look smooth without the need of actually making the in-betweens by hand. Okay, so those are a couple of examples. Let me reset my layout to show you real quick how to do something like this from scratch. So I will start here with nothing, sorry. And I have my atlas over here. I'm going to create one animation for the golem that I showed you previously. So I have all these textures, all these sprites in a single texture. Why do I want to do this instead of having the sprites across my, different files? Well, for instance, if I have them on the same sprite, even if I render more than a couple of sprites in Unity, I will get just one. I will batch them together. Unity will batch them together. So it's a good idea to have all your small sprites into a single texture whenever it's possible. So as you can see here I have multiple pieces of my character. And the regular workflow of adding these sprites into my Unity scene will be to just drag and drop the sprites, right? So you will do something like drag and drop it here. However, since we are using Animate 2D, we need to do a couple of steps in the middle. So what I need to do is I will select something like this golem's upper head. I will right-click, create, go to Animate. You can see here, I went from right-click, create, Animate 2D, and I will create a new type of asset called sprite mesh. Right? This is what Animate 2D will use to actually render my sprites. So I need to do that for the pieces that I want to use as sprites, which are called sprite meshes. So I drag and drop that here into my scene. And I will do the same for the lower part of the head, the jaw. So I go create, Animate 2D, sprite mesh, drag and drop, and I put it somewhere here, right? So you probably see where I want to go. I basically want to achieve something like chewing animation. The first thing that we see here, the issue is the ordering layers. So we can fix that in a super simple way, just by changing the sorting layer. I can make it smaller, the value of the sorting layer of the jaw. Then imagine this is the character. I'm not going to animate the whole character. The next thing I want to do is to start creating the rig, the skeleton. So I go here, right-click to the object, and then I select a bone. I created a bone. This is the bone. I can move it over here, but again, I don't want to move it. I will start with something, let's say like this. This will be the root of my skeleton, of my rig. Then I want to create another bone to control the upper part of the head, and another one for the lower part of the head. So by selecting that bone, I right-click to the object, bone, and I will put the bone somewhere here with this rotation. I want to create another that controls the lower part, so I select the first one, right-click to the object, and then bone. Sorry if it's too small over there. Okay. This bone will be somewhere here. Okay, so I have my rig. It's a super simple rig. Maybe if I actually wanted to make my character, this wouldn't work, but just for example, if I want, or if I move the bone over here, nothing moves on the other, on the sprite mesh. I need to bind the bone with whatever I want to render. So for that, I will select, and this is why we created a sprite mesh object and not regular Unity sprites. So I will select the upper part of the head, this rock column atlas. I will select the sprite mesh here, and I will edit sprite mesh. Oh, I need to tell which bone I want to use for that one. So it's going to be the first one here. And for the lower part of the head, I will use the other bone. I'm setting the bones here. So I'm just dragging and dropping the bone that I know I want to bind to that specific sprite mesh. So I'll go back here. I open the sprite mesh editor, and I tell, oh, okay, here. I want to bind the bone that I had created. You can see it over here. I'm going to tell this sprite mesh, oh, you know, this bone will be bind to you. So I will bind it over here. You see that it changes the color. Also, a cool thing about the sprite mesh editor is that we can actually change the geometry. By default, Animate 2D will try to create a geometry that it knows will fit your sprite mesh. However, if you know that you will be making some sort of different animations and you want to tessellate the sprite a bit more, you have full control over how to set your vertices over here. I will leave them as they are there. It's already binded. I just need to click apply. If you have used sprite editor, this will be super easy to use. So now it's binded. If I move the skeleton, I'm moving the bone, sorry, in my skeleton, and the other part moves as well. So I'm going to do the same thing. I click on the sprite mesh of the jaw of my golem. I already have the bone here. No, I have to assign it. Then I will select the bone, select the sprite mesh that I want to bind. See how, in this case, Animate 2D decided to create something similar to a quad. In fact, there's something weird here because I have a vertex over here that maybe is not something that I want to have. I can remove the vertices, etc. I can create more vertices in case I want to do something special, etc. If you're an artist, you might know which geometry you want to use. In this case, I will just leave it something like this. Click apply again. And then I have, oh, did I forget to click apply? I think I did. Just 1 second, I think I did something. Oh, yeah, sorry. I forgot to bind the actual bone to the sprite mesh. So I do that, click apply. And then if I move the other bone, I have the actual rig that is now working, right? In this case, I will do something like this. If I want to create an animation, I will just need to add an Animator Controller and start creating the animations as we see somewhere here, right? I name my animation 2. And I will just be moving my bones, not the objects. So sorry, I'm not an artist. I'm doing my best here. Well, I don't know what I did wrong. Anyway, that will be the flow to animate. We have the a complete and correct character over here. So if you want to see how this was made with more time, etc., how this was constructed, see how you can achieve stuff like this. That I think it's important to mention that we even added a rig here for facial animation, right? Maybe you don't need this. It depends on what you want to achieve. Finally, I want to show you, and if you stick around, the next presentation is by the product manager of Unity 2D. So if you have more questions, etc., he will be presenting a lot of cool stuff that we are working on. So regarding 2D animation, where are we heading to? We are basically working on an integrated solution for you to be able to animate within Unity, similar to what I showed you today, but with a better workflow, with a workflow that actually fits how the rest of Unity works, which consists of creating, editing bones, hierarchies, etc. Everything with what you already know of Unity. An automatic and manual way of tessellating, which is creating more or less geometry for your sprite meshes. A way to assign the weights. I didn't show that because it was super simple, my example, but you can assign how much importance one bone has over which vertices. Freeform deformation, so you will be able to actually deform the meshes for your animations, and the inverse kinematics. Also, everything I'm telling you about integrated into Unity. And finally, here's what's coming. So if you're interested in getting the project I showed you, with the one with the character, the female character, and the slides, you can find them on GitHub. You can do whatever you want with those. The code is there. Just make sure you play around, you learn from that. Also, the Animate 2D package is over there. And if you want to know more, there's a cool 2D presentation also from a Unity guy on YouTube. I think we have a couple of minutes for questions. I will be outside for the rest of the day, so if you have questions afterwards, I can answer them. Ross is also here. I think, oh, he's over there. He's the next speaker. So if you have more questions regarding 2D animation or basically any 2D related stuff, he's the guy you want to talk with. So thank you very much. Have a great rest of the day.